in the exploration of perpendicular bisectors and circumcenters, what we're going to do is we're going to start off by drawing a triangle. So we're going to use our polygon tool, go under polygons here. We're going to create any triangle that we want. It doesn't matter shape or size right now. What we're going to do for the perpendicular bisectors is we first need to evaluate what the term perpendicular bisector means. The perpendicular part of it tells us that we're looking at something that is going to be perpendicular to the sides of the triangle. That means it's intersecting with the triangle, forming a 90-degree angle. And it's going to also bisect each side as it does form that 90-degree angle. So the bisect part is the first part we're going to focus on here. To focus on that, we're going to look at the midpoint. Midpoint here is under the construction tools. It is where we got the 3 points in a row with a red point in the middle. That'll help us find the midpoint of each side. So we simply select that icon and then select each of the sides. That will give us the midpoint of each side of our triangle. Now we're going to draw the perpendicular that goes through that point. So to use that, we're going to use our perpendicular tool, which is right next to our midpoint tool. We select that tool. We are going to select the point that we want to be perpendicular to, and then the side that we want to be perpendicular to. It should draw a perpendicular line through our point. We will do that for each of the midpoints that we drew. So we want to be perpendicular to point E and go through side AB. And then we want to be perpendicular to F and go through side AC. That gives us all 3 perpendicular bisectors of a triangle. Every triangle will have 3 perpendicular bisectors, 1 for each side. Those 3 perpendicular bisectors, you'll see they all intersect at the exact same point. So I'm going to use the intersection icon here to identify that point. All I have to do is show the intersection of 2 of the perpendicular bisectors, because the third one will always intersect at that exact same point. Now, as I see here, the way it's drawn, we have that those 3 perpendicular bisectors intersecting outside of our triangle. That intersection is what we call the circumcenter of the triangle. We're going to use our selection tool here, and we're going to take a look at where that circumcenter is located. It's kind of weird that it's outside of the triangle, so we're going to evaluate what happens as we move our triangle's points around. As we move our triangle's points around, we can see that that circumcenter has now moved to the inside of the triangle. Now it's right on the edge of the triangle, and again, it is now on the outside of the triangle. What you'll notice is whenever this triangle is an obtuse triangle, so I can move this out here, overemphasizing the point that this is a obtuse angle here at vertex C. You can see that the circumcenter is way off our screen out there. I can bring it back into our screen a little bit by moving point A. There's our circumcenter way outside of our triangle. We have an obtuse triangle. As we move this triangle around, I'll try to set this up so it's a little more clear of when it lines up exactly on the triangle. There we go. So you can see here it is a right triangle when the circumcenter is on the edge of the triangle. And as it moves to the inside of the triangle, we'll manipulate this around a little bit. As it's on the interior of the triangle, this is an acute triangle. So the 3 phases of a circumcenter is it is outside of the triangle when it's obtuse, it's inside the triangle when it's acute, it's on the edge of the triangle when it is a right triangle. Now this circumcenter has a certain characteristic to it which makes it very important. That characteristic can be seen when we draw a circle with it. We draw a circle with the circumcenter being the center of the circle, and we take a look at what happens when we put one of the vertices on the edge of the circle. So we got our center at point G, one of the points here, B, being on the edge of the circle. When we set up that circle, what happens is that circle actually doesn't just cross at B, it also crosses at points A and C. We'll shrink this down a little bit so you can see it a little bit better. So with a center at G and a point on the circle at B, it hits all three vertices of the triangle. Now, what we know about circles and what the important part about the circle is that every radius in the circle is the exact same length. So what that means to us is that the circumcenter is the exact same length away from all 3 points of the triangle. So to put that into a real world context, what I'm going to do here is I'm going to insert a picture. I used a picture of the Twin Cities metro area for this example. We'll increase the size of this picture to make it a little more usable. Okay, that should be good. Now, we could say, let's say, for example, we live in Brooklyn Center, which is right here. Let's say our main focus of our business, we're going to be talking about a kind of a business model here, being that we want to look for a location of where we want to build our business. So if we live in Brooklyn Center, and let's say we work at the fairgrounds at the State Fair, which is in Falcon Heights here. We'll move this over a little bit here. We're a little bit east of Snelling Avenue there in Falcon Heights. That's where our State Fairgrounds is in Minnesota. And we want easy access to our airport. Here's the Minneapolis-St. Paul International Airport right here. So if we look at those locations here, the Circumcenter would tell us a location that we could put our business so that it's the exact same distance away from our house in Brooklyn Center, our work, which is at the State Fairgrounds in Falcon Heights, and the Minneapolis-St. Paul Airport, so that we could be the same distance away from all 3 locations, which would put us here close to St. Louis Park. That would be a good real-world example of what we're talking about here with the Circumcenter, being the same distance away from all 3 points of a triangle.